In this problem, we're asked to find V0 using Thevenin's theorem, and we're going to use a problem-solving strategy entitled Applying Thevenin's theorem. And if you'll look, step 1 in that strategy says remove the load and find the voltage across the open circuit terminals. First thing we need to do is identify the load. Since we're going to calculate V0, let's treat this 1 kilo ohm resistor as the load, and then in applying Thevenin's theorem, we're going to calculate the Thevenin equivalent circuit, which consists of the open circuit voltage and the Thevenin resistance. I'm going to label these terminals A and B, and then what we'll do after we find the Thevenin equivalent is we're going to connect the 1 kilo ohm resistor to the Thevenin equivalent, and then we'll calculate V0 from that. So our first step is to find the open circuit voltage. So let's remove the 1 kilo ohm resistor. Here's our circuit for calculating the open circuit. Note that we've removed that resistor. Here's our circuit. Now if we look, we can use any of the techniques that we've learned previously to do this calculation. If we think about our two main techniques, nodal and mesh, if we look at nodal, we could do it with nodal. We'd have, for instance, we pick the reference node, we'd have 1, 2, 3, possibly 4 node voltages. If we do it with mesh analysis, since we have current sources, we know that in mesh analysis, every time we have a current source, that gives us a constraint equation. But if we pick mesh currents, then our constraint equations are very easy here. So let's use mesh analysis. So let's call this one I1, this one I2, and this one I3. So we have 3 mesh currents, I1, I2, and I3. We have 2 current sources, so we're going to have a constraint equation. We're going to have 2 constraint equations, so that's really only going to leave us 1 unknown mesh current. So for instance, I1 is equal to 8 milliamps as a constraint equation, and I2 is equal to 2 milliamps is our other constraint equation. So here are 2 of our 3 equations. For our third equation, we'll apply KVL to this mesh. So the equation is 3K times I3 minus I1 plus 6K times I3 minus I2 plus 6K times I3 is equal to minus 12. So that's KVL for this mesh in the middle. Collecting terms, we have minus 3K I1 minus 6K I2 plus 15K I3 equal to minus 12. Now we can substitute our constraint equations in. So we'll have minus 3K times 8 milliamps minus 6K times 2 milliamps plus 15K I3 equal to minus 12. And that reduces, let's see, minus 24 minus 12 plus 15K I3 equal to minus 12. That's going to give us 15K I3 equal 24, or I3 equal 1.6 milliamps. Now, we still need to find the open circuit. This just found the mesh currents. Now to find the open circuit, we can apply KVL around this loop. And if we look, for instance, I2 flows through this resistance. I2 is 2 milliamps. So the voltage across that resistor is 4 volts. So now let's apply KVL to that loop. So we'll have V open circuit is equal to 4 plus 6K I3 plus 12. So V open circuit then is 4 plus 6K times 1.6 milliamps plus 12. And that gets us 25.6 volts. Okay, so that is the value for V open circuit. Now we need to calculate R Thevenin. Now we know that our circuit doesn't have any dependent sources, so we can find R Thevenin by taking the network and setting those sources to 0. So if we look back at our original circuit, here are a couple of current sources and a voltage source. If we turn this to 0, this becomes an open, this becomes an open, and this becomes a short. We turn it to 0, that's 0 volts. So we're left with the following circuit from which to calculate R Thevenin. So we can do this by resistor combinations. So for instance, these two resistors can be combined in series. Our circuit can be reduced to the following. And if we take these two resistors and combine them in parallel, so 6K times 9K over 6K plus 9K, that gets us 3.6 kiloohms. So then R Thevenin, we can calculate from this circuit. We have 2 kiloohms, 3.6 kiloohms, so R Thevenin is 5.6 kiloohms. So now we've calculated our Thevenin equivalent. So our Thevenin equivalent then, R Thevenin is 5.6 kiloohms. Open circuit voltage is 25.6 volts. Now we're going to hook up the 1 kilo ohm resistor and calculate the voltage V0. And we can do this by voltage division. So 25.6 times 1K over 1K plus 5.6K gives us 3.88 volts.